Okay, now we are 2 minutes past the half hour. It's time to get started. Welcome, everyone. This is the Thing to Thing Research Group, our summer meeting. My name is Ari Keränen, one of the chairs of the group, and Karsten Borman is the co-chair. He's just coming from another session, on IAB session, joining this in a minute. Quick reminder to everyone, since this is an IRTF session, the note well applies. So we are recording the session, be nice to everyone, and also the IPR guidelines of the IETF apply. The longer version of the note well is covered by the following 2 slides. If you have any question on this, please do read the recommended RFCs or do reach out to the chairs for more details, both on the code of conduct and the intellectual property. Also, quick reminder about the goals of the IRTF. So here at the IRTF, we focus on long-term research issues that relate to the internet, whereas our parallel organization, IETF, focus on the shorter-term issues of engineering and standards making. So here at the IETF, we conduct research and not doing standards development as the IETF does. But however, we do publish information on experimental documents in the RFC series, primarily as a way to promote development of research collaboration and teamwork on the topics that are relevant for us. A few notes on the administrative end. So we have online note-taking using the notes IETF.org. The chairs will be taking notes, but we do welcome everyone to join on the note-taking. So always more fun and better on collaborative fashion. We do have a mailing list where we recommend you to join if you haven't already, the ThinkThinkRG at IRTF.org. There's a link how you can subscribe there. And as usual with our sessions, we do have a GitHub repository for this session where we have the agenda, materials, related links, etc. stored. A quick reminder on the ThinkThinkRG scope and goals. So here where we focus is on open research issues in turning through Internet of Things into reality. In particular, an internet where also the low resource nodes can communicate among themselves and with the wider internet. And we focus here on the topic of IoT and issues with opportunities for IETF standardization. So usually starting at the IP adaptation layer and going all the way up to application layer, including architectures, APIs, data management, security, etc. There are a few groups that we work in particular closely at the IETF side. So for example, core, where there's a lot of work on protocols and data models, and also more recently with ASDF, which is engineering format for IoT model convergence. And then, for example, groups like LWIC and IoT Ops, where it's more recommendations for operational issues when it comes to IoT. But usually how it happens that we look at RG, the more longer term issues on these topics, and when there's need to write standards on the topic, that work is done on the IETF side. So right now we are having a summary meeting. So these are meetings that we have roughly once per IETF, more recently before or after the IETFs, where we give an overview of the activities that are happening in the ThinkThinkRG scope. But we do have also other meetings that we have in between. In particular, we have had quite some time wishing meetings on a varying cadence, sometimes once a quarter, sometimes more often. We're planning to continue those. And we also now are starting a new series on the topic of security on the Secore, which Göran will be talk more rather soon. Also, we are planning to have summer meetings like this, also before or after the next 2 IETFs. And also, we have had in the past very many successful meetings with other SDOs, Alliance Operations communities on the relevant topics. So we will be very much open having more of those, but we don't have anything scheduled at the moment. And also, we will be having work meetings where we go in more details on specific topics. For example, we had one on digital twins not that long ago, where we take a specific topic and work more specifically on that. We are also planning to have finally physical meetings someday soon, of course not this year, but next year we are tentatively discussing to have one before the Prague IETF, have a, for example, half a day or full day workshop on the topics relevant for ThinkThinkRG. So please stay tuned, more on that coming soon. And we have had quite some time planned to have an online co-locating academic conferences. We haven't been very successful on that, but if you are aware of or perhaps even organizing a conference that is of relevance to this group, we'd be very, very happy to talk with you. So please do let us chairs know. A few words about the research group document status. The document on Edge and IoT is currently has passed the research group last call and IETF chair review, and it's going to IRSG review now. The other research group document we have on the RESTful design for IoT is we're currently waiting a couple of more PRs to come, and then we should be soon going to research group last call also on that topic. And then we have the document on terminology and processes for initial security of setup of IoT devices, formerly known as secure IT bootstrapping, that we get a quick update on the following slide. We have also a set of documents that are not currently research group documents, which most of them are essentially looking for more feedback, and in particular, the semantic landscape document or nutrition labels for IoT is something would be very much appreciate more input and feedback on, in addition to all the documents that we have today on agenda. So next, a quick update on the secure bootstrapping draft. Do we have Dan?
Yes, this is Dan, one of the co-authors of the draft. So just very quickly, to let you know, in this version, we have completely assumed the new terminology used. In this sense, we are using the terms entities or players involved in the different processes and terminologies regarding the initial processes like bootstrapping, provisioning, onboarding, etc. So we analyze different players involved in different proposals or standards. We also go over the different initial assumptions about the devices involved and the different processes that need to be completed to have the device completely operational. And also we go over the different knowledge imparted to the device before the different processes for it to become operational, and the knowledge imparted after the processes have been completed. And we go over as well in a comparison of the different processes involved for the different standards and protocols reviewed. So any feedback and review is welcome as we work towards the next version, in which I think we need to update some of the protocols for a new version that arose not so long ago. So again, any review and feedback is welcome.
Excellent, thank you, Dan. I see we have Michael on the queue. Go ahead, Michael.
Hi, thanks. So it would be interesting to get this document back in its progressing. I think one of the most important things that we need to do is kind of step forward since the document was started, and we need to make sure that we're not using the word bootstrapping, and because the industry's kind of moved on to the word onboarding, which Brewski didn't get right either, and so I think that actually is probably the most important thing, is because nobody knows what bootstrapping is anymore. So that's what I would say is we need to have a top to bottom, assuming it's 2022 and not, this document's been sitting around a long time, and I think it's okay for us to say that we had these old terms and that we have some new terminology that is there. So I'd be happy to send you some pull requests and stuff like that. But I think we need a working group wide consensus to change the title of the document.
So thank you, Michael. Just a quick note: the title was already changed. So now the title is Terminology and Processes for Initial Security Setup of IoT Devices. Bootstrapping is actually removed from the new title. And what I would just say is that we try not to focus or favor any of the specific terminologies, but we just try to review the different terms that different protocols and standards use, sometimes interchangeably, like bootstrapping, provisioning. So if we do not mention bootstrapping, maybe the process cannot be understood when we read some of the protocols, right? So in some protocols or standards, bootstrapping is used, and others provisioning, onboarding, enrollment, etc. So
But
the
what
viewer,
I'm trying to say is that actually people have come to some consensus about what the different terms mean, and that provisioning is not onboarding, and that provisioning has a very specific thing. And so I think we need to walk through the document and we need to rewrite it. Like even in section 2, it talks about DPP has bootstrapping information, and it doesn't. It is provisioned with onboarding information, right? And I think that's just really important for us to get on top of that. And I think that's actually the major contribution of this document, is to nail down those terms for everybody.
okay, thank you.
Yeah, I would just add that we can recognize industry terms, and of course should be using them where useful. We also have to keep in mind that industry terms are not always very sharply defined, and where we find that an industry term actually is ambiguous, we may want to define some of our own terms, or qualify the industry term with another adjective or something like that, to make sure we have really well-defined terms. But I agree with Michael that getting the terminology right really is a major part of this document.
Okay, thank you very much. So as Michael commented, if you can please maybe through the mailing list or a pull request, so we can focus the work from this point on. Thank you.
Great. Thank you, Dan, and thank you, everyone, for the comments. So I think we have a good way forward here. Then moving on the agenda. So now we are finishing the intro and RG status segment. Next, we have a segment coming on security topics. So Göran Selander will start with the update on Secora work, and Jon Mattsson will continue on the update on the application attacks using CoAP. And then finally, Michael Richardson will get an update on the taxonomy of operational security considerations for manufacturer installed keys and trust anchors work. After the security segment, we have a semantic interoperability segment where Michael Koster will start with the 1DM and IT schema update, followed by Karsten with an update on SDF. And then Jan Roman will give a brief update on the W3C Web of Things and talk about his work on SDF Web of Things conversions. And then finally, Ale and Bin will give a talk about their work on knowledge graphs for IoT platform digital twins based on SDF. And then around 1725 UTC, we should be wrapping up and concluding the meeting. Any questions or comments on the agenda for today? Okay, in that case, let me share the slides for Göran, and Göran, you can go ahead in a second.
Hello, can you hear me? Can you hear me?
Yes, we can.
Thank you. Okay, so this will be short because I don't have so much updates. Just informing you about the new topic, the new activity called SecCore, Security for Constrained RESTful Environments. Or if it had been Italian, it could mean dryness, or SecCore or something like that. So that's so I only have one slide. Please go to the next one.
Actually, you should have a control now.
Oh, thank you. It says Ari Keranen slides here, but I think I have control. Yes, thank you. So as I mentioned, this is a new activity. We have got some good feedback, but we are still looking for drivers, or what we might call pen holders for the topics, who's basically taking some sort of administrative responsibility for the progress of the work. And we have had in the previous meeting, we went through a number of different topics, and there are some topics which has raised some more interest than others. There is already ongoing work about amplification attacks, which John will talk about next. But there are also two candidate topics which seem to, has more ideas attached to it, and we'd like to get back to in a later meeting. And one of those deals with software update using co-op group communication. So it's the idea around how to make software update more efficient using multicast or other group communication mechanisms. And the second topic relates to delegation of rights, in particular in the ACE OAuth setting. So that's also an interesting topic, and which we didn't cover in the ACE work, and which might benefit from first a research activity. So those are two topics where there is some ideas already, and we're just waiting for people to have time to be engaged in this and bring it forward to the working group. And if there are other people who are interested in some other topics, either those in the list we discussed last meeting, or some other topics related to the topic of this working group and also fitting into the charter of T2TRG, that's of course welcome. So yeah, please join the work. Any questions or comments? Okay, then I'm done. Thank you.
Thank you, Göran. Maybe one quick question, like, would you expect there to be a follow-up meetings sometime in the near future, and what's the right place for people to hear about them? Is it notifications come to the list, or what's the best way?
I think the idea of having meetings somehow relate in the same pace as the IETF meetings, either before or after or during, I think that's a reasonable tempo given the commitment of other people who also are interested in this area but don't have the time to contribute. So that's my expectation. So in terms of, but if other people are interested in driving some things, we can of course have more frequent meetings.
Great, thank you, Göran.
Thank you.
Any more comments or questions here? Okay, then let's move on. Next is Jon to talk about the application attacks, and let me pass the slide control. And you can actually request to share the preloaded slides. Yes.
Let's see there. Do you hear me?
How we can see them? We can hear and we can see your slides. Thank you.
Yeah, great. I had some audio problems, but it was some network problem. I switched to mobile and it works, but I will not use any camera. So hopefully the audio will work fine. So this is follow-up presentation on the amplification attack draft. So we have submitted a 0.2 version, I don't know, 1 month ago or so, with basically fixing all the comments and issues known at the time. A lot of some editorial work, updated some references, updated some text in the draft that was better written in the slides for the last T2TRG presentation, and then addressed some comments from Achim to how calculation of the amplification factor, that depending on where in the stack you calculated, you might end up with different things. Just some clarification that you might get different things, but depending on where you calculate them, sometimes one option makes more sense than another. Then there was some error in the draft received from attacker is now stated instead of sent from the attacker. Then we have after 02, see how do I there. Received quite a lot of new comments on GitHub. There's best request from a researcher that wants he wanted implementations of the amplification attack. Sent him several emails that this is mostly a theoretical work. He has to implement it himself, but that is quite easy, and giving him links to different co-op implementations and explain how to high level to implement it. Then there are quite a lot of good comments. I think most of them hopefully quite small from Achim that will be handled for the 03 draft. There is some explanation and some corrections that needs to be done in the draft. Maybe the biggest thing is adding proposals for mitigation. There are some text on mitigations right now, but probably not enough. High level, what's the future of this document? We have seen gotten quite a lot of good comments and issues about like small technical details. But I think important question for the research group is what is the long-term goal and scope of this document? My own view is that it should raise awareness of IoT amplification attacks in general. As pointed out by Achim, it should probably also talk about mitigations as much as we know. Question that could be discussed is whether it should discuss non-amplification denial of service attacks. I don't know, probably not, but if there are material, then why not? But this typically involved hacking devices and so on, so it's quite a different attacks than amplification attacks. Amplification attacks is also something IETF can mitigate with the protocols. Hardening devices is different thing. And then the fourth thing that is, should the document include concrete information about actual attacks? There's previous, we have definitely discussed this. It was important part of the discussion why this is important. There was request for newer and more concrete information about actual attacks. We have tried to make the information a little bit better, but the reality is that there are little new and concrete information out there. The information given by various security companies monitoring these kind of things are very limited. And some of the media reporting on things are maybe more confusing than helping. It's very easy to see that some of the one suggestion would be, my suggestion to maybe completely remove this part from the draft. It's maybe more confusing than helping. Some other comments from also relate actual attacks from Achim is to not paint it black, maybe especially regarding co-op. I think removing this text about actual attack is first step. Could also maybe make the high level document less co-op focused. The current title is Amplification Attacks Using Co-op. I think the main goal of the document is maybe to raise awareness of IoT amplification attacks in general. So I think maybe high level the document could be less co-op focused. I think the examples are probably, or most of the examples are probably best to keep in co-op. That's the most relevant IETF IoT protocol. And then I think the document is in a quite good shape, so maybe research group adoption. And that was my short presentation.
Great, thank you, John. Any questions or comments on the draft so far? While you think about your questions and comments, what we're thinking of is doing a show of hands in the Mitaco tool for those who think we should be adopting this document. So now you should actually see it in Mitaco. Okay, so this is for a question who has read a version of this document. And you can either click raise hand or do not raise hand. Okay, seems we actually have quite many people. I see 6 raised hands in Mitaco. Okay, thank you everyone for answering on that poll. So should we do another one on, since quite a few have actually read it, what's your take on adopting? Okay, so now you have another poll ongoing. Please raise your hand if you would be in favor of adopting the document. And as usual, of course, this is just the first version of a document that we'll be then continuing working together with the whole research group.
Yeah, so there are actually several ways in which we can adopt a document, so we can actually achieve research group consensus, so we all agree on what's in the document, or we can simply agree that this is useful information to have published, even if we don't necessarily agree with all the details. I think we can decide what we want to do when the document is already adopted. My take of the discussion so far would be we should be able to get a research group consensus on this, which I continue to believe until we actually get disagreement. So I'm ending the poll in 3 seconds. Okay. So we have 8 people in favor of adoption. One hand that was explicitly not raised. And for this, I actually would be interested if you want. Can you tell us why you don't think this should be adopted by the research group? Okay, so this is an anonymous call, so you are very much free not to answer my question, but it would be interesting to hear the answer.
And as usual, feel free to comment on the list, or if you wish, directly to the chairs if you have anything you need to comment on. And of course, we'll confirm the call on the list as usual. But it seems that we have a quite good support on working on this topic. Okay, thank you, John. Thank you, everyone. Any more comments and questions here before we move forward? Okay, then next we have Michael Richardson. Michael, would you like to request sharing, or do you want me to initiate?
You have the slides and you can give me control.
Yes, I can do that.
Cool. And
now you should have the control.
Okay. Thank you. So I'm going to make this quicker. I thought I had was expected to provide more time. That's why I made so many slides. Thank you for the extra time. So I've had this document and taxonomy of operational security considerations for manufacturer installed keys and trust anchors. It's quite a mouthful, and I would be happy to shorten it if people had a good way of shortening it without losing detail. Anyway, so history of the draft. So it started in 2020. It actually, first of all, was in this document, this anime document called Massa Considerations, where I felt I needed to give some advice to enterprises or manufacturers about how to build their IDEV ID, their 8021AR keys. And people have been asking for it. And the other thing that I experienced in 2020 was that there was a fair bit of pushback on things like Brewski, and now actually Matter has the same issue, and DPP as well, about whether or not manufacturers would ever actually put birth certificates in their devices. And if they did, could we ever trust them to have gotten it right? And specifically, there was basically a lot of cynicism that these keys would actually ever be kind of secure in any way. And I was a bit surprised by that, considering that we've had, workshops, security workshops on IoT that I think the Paris one, I think, is 2012. Is that really 10 years ago? When we heard from various entities that they were putting IDEV ID keys in their VoIP phones for, more than 5 years already. So at this point now we're talking like it's 15 years ago that people started doing this. And the other interesting thing was that I came to realize that a bunch of people that were pushing back on this didn't know their companies already did it. So, we couldn't possibly do this. And it's like, well, actually, you're doing it. And the reason why it turns out that people don't know about this is because this process is all shrouded in secrecy of NDAs and this kind of thing. So this document evolved, and we went to Sec Dispatch at IETF 108 in the summer, and Sec Dispatch says, please go take it out to industry, talk to people, find out if people really relevant to this, really get this. And then the suggestion was to bring it to the T2TRG in 2021, and we did some presentations in 2021. And there's now been I've probably done about 10 presentations to various places, some of them quite big groups. And some quite privately with a fair bit of nodding. And in fact, one or two manufacturers that say, I have dozens of NDAs with customers and I cannot even discuss with customer A how they could simplify things by doing what customer B did, because of course both of them are under NDA and they can't talk about them. And they were kind of saying, well, if only I could refer to some external source that was public, that would allow me to say, well, could we simplify this and what terminology could we use? And then everyone might actually be able to have fewer code paths. And so there was a fair bit of interest there. And there's also some work happening at NIST right now to kind of write some of the processes that some of these people are doing down in actual more detail, rather than what this document does, which really is just to provide some taxonomy. So there's some images from the talks. There's some links here. If you really want to go see the talks again, they're linkable there. And that last set of talks, it's the same talk, but in some cases there's 3 different videos of it that'll be up. So you may remember this, remember that time we did that. I'm not going to go through the content, but non-goals of the document. Okay, so this is not an ISO 27,000-ish or 14,000-ish evaluation process. I'm not going to tell you in this how to do your auditing. Okay, and not the goal of this document is also not to say what is more secure. What we're actually trying to do is simply say what is, and that's the really the first part, right? So we want to say, this is what you need to go. This is a certificate we have on appliances in Canada. tells you how energy efficient or not they are. And you can see in this example, it's far to the left. It's really not very energy efficient. And you know what? That's actually sometimes okay. You know what? You're okay with buying a cheap refrigerator or microwave that you don't use very often. And so the fact that it's energy inefficient doesn't actually matter because you hardly ever use it. So what we're kind of looking at is, this is just the numbers here. And, you know, this Cheetos holding the closet shut, you know what? That actually might be an appropriate level of security for some class of devices. And the only important thing is that you recognize when that's what you're buying. And when you're buying something super more secure, you recognize that, and you see that there's a difference in the price. And that's okay, because they can tell you what the difference in the security is in a reasonable way. One of the things that comes out of this document is a way to count and number PKI levels. Not going to talk a lot about that now. How is the key generated? Still unhappy about some of the naming. I'd like better names. No one's come up with a thing. Everyone seems to hate the third name, but I don't have a better name at this point. And then how do you deal with descriptions of business continuity about secret sharing? What do you publish and what do you not publish? And what I believe that the answer is that you're gonna say publish n minus k as a something that you can share without actually telling anyone n or k. So if you have 7 pieces and you need 4 of them to reconstruct a key, then the answer is you have this you have a redundancy of 3, which means that, you know, it also is a little bit like people might say bus count, which is how many people you can lose from your team before your project is unviable for that. And there's an example, right, of what people were talking about. You split off these keys, they have different pieces, they go different places, and you need to know how many there. One of the conclusions is that you might never even publish the list of who has the keys externally, obviously, but you might not even tell the board of directors. Okay, that actually also might be something that you might not do, but it's not really our problem. But you think about the different situations of how that's going to work. So next stop, and get documented document adopted. There's some wordsmithing and maybe some bike shedding over some terminology that I would like to have happen. I think we need to talk about the resulting terminology widely. And we need to listen to, while we're talking, we need to listen carefully to the expressions on people's faces and see, you know, where there's still some awkwardness or some disagreement or something like this, and figure out what that is in there. And I'd love to publish it in late 2023. That would be my schedule and goal. Good enough?
Great. So as we said, we really are in need of stable terminology. So this is really an important contribution this document can make. And I think by actually phrasing it as a terminology document and less of an evaluation and recommendation document, it will be easier for us to actually achieve a research group consensus on actually publishing this. So I'm going to ask the same questions again. So who has read a version of this document? Yeah,
More people have not than have so far.
yes. So, Michael, would the current version be a good version to read, or do you want to make some changes?
So there is an update that was done just before the IETF, I think it was. That version is pretty stable, and I'm very happy with it. There's, you know, there's still some gaps in it, but I think it's 92% of the way there.
Okay,
so
we can recommend reading that, and actually we could underscore the need to read this now by actually going for a call for a research group adoption. So of the people who actually have read the thing, who is in favor of research group adoption. Obviously, we will have to complement this with voices from the mailing list. So everybody who has read it, plus one more, are in favor of research group adoption. Oh, wow. Okay, that gets better and better. 6. Okay, so this looks like we have strong support for doing this, and we should actually issue the call for adoption on the mailing list with this as input and get people to read and review it. Thank you.
Thanks.
Great. Thank you, Michael. So very good progress also here. Any final questions or comments on that topic before we move forward? We're actually nicely on time even. Okay, so next we have moving to the semantic interoperability segment. And first we have Michael Koster and the 1D and IT schema update. So Michael, do you want to request this sharing or should I share?
I only have 2 slides, so if you could just do that, that would be fine.
Yes, and I can pass you the control.
We have an update on the One Data Model liaison organization and also IoT schema, basically the organizations that are attempting to capture industry data models and publish them in a consistent format. So go ahead and show my next slide, please.
Yeah, actually, I passed you the control, so you can.
Oh, you did.
Change them.
Okay, so all I have to do is find it.
Yeah, in the bottom of the slides, you should have the control.
Yeah, you can just press
Oh, okay,
cursor right.
no, there it is. There it is. Never mind. Okay, so One Data Model, we've been going for a while now, and I think without giving people a lot of unnecessary background, the focus of the organization, we've really shifted in the last year. The news is that rather than driving toward model convergence and coming up with a single model for how everyone should model a light switch or how everyone should model, a pressure transducer or whatever, we basically recognized that the industry isn't really ready to go do that at this point anyway, and that's a lot of work and a big lift, and we're going to move that into the background. What we really need is to get more contributions, to get people to sort of, build out that first step where we have now almost a standard language. We have SDF, which is almost there, and we'll hear more about that later. But basically, to get everyone to bring what they have in this format and then work on the convergence from there, and that will in really 2 ways. So we're basically opening up so that people can create their own repository in the One Data Model space and use the CI tools and basically enforce a set of common practices and common patterns on top of that. So that's kind of what we're working for right now. And the technical work is focusing on the semantic proxy and mappings and binding. So I guess you'd say we're sort of taking a more long-term view of the model harmonization approach to get everyone to use the same model. And that will probably happen over time, but that will make it easier to happen if we support translation and semantic proxy and mappings and bindings. And so that's really what where the focus is. That's really the big news. Now, we've got this set up already, so anyone can come and open up a repo and start downloading their models. And we've done this already with OMA and OCF. Those 2 organizations are pretty far along. We're just starting on Bluetooth, and initially we're going to look at modeling the characteristics and the mesh device properties, which are both I guess they're non-IPR encumbered. They only have copyright rules, so we don't have to worry about the next level of agreement to publish them. And they're basically data models. So but with Bluetooth mesh, they embody a lot of the semantics of what's happening in the data types. So I think that's a good direction. And we're also reaching out to CSA to Matter now that they have launched, now that they have, they're calling their data model ... So originally ... was going to be the Zigbee cluster library over IP networks, but now they've sort of branded the data model as ... It's still planned to be open, but so we're reaching out to them to see how we can work together to, you know, whether we're going to publish that or exactly how that's going to work. Now that we have all these tools, we can offer a low bar for them to participate in using SDF to model. And currently they have XML, and it's based on a lot of earlier tool sets from Zigbee. So I think it might be a good thing for them to look at, but we're still in the reaching out phase there. And the third thing that's happening, I think, with one data model of note is that we're looking at broadening things out now that we have, anyone can just come and add models. We're looking mostly at, I think, digital twin models, and the use case, we're focusing on really looking at whether we have everything we need to do that modeling. And I think the big gap appears to be sort of, how do we model relations and links and things that are coming from ontologies and graphs. And so we're really building out our use cases for SDF to support both abstract references in the modeling and links in a bodied graph that uses the model. We have some DTDL, Azure DTDL, I guess, interworking that we're working on to test some of this out, but we're looking for some other use cases. You know, we'd like to do OPC UA and find some other people who are using, and I've privately done some similar modeling myself that I can't quite share yet, but there'll be some public stuff coming out at some point. I think that's pretty much the three main points for one data model, but I'd like to open it up and see if Ari or Karsten or some of the other folks, Jan, who've been participating in one data model, have anything to add to that, or if there are any other questions or comments. Okay, well, if something occurs to anyone, please just speak up. I see Milan is unmuted. Okay, yeah, Milan, please.
Yeah, hi, Michael and others. I just want to clarify, you said the focus is now to convert for people to bring and contribute models. But with what intent? Is it for one DN to then map them to a common model representation, or simply to have a view of what's going on out there and just, is it to increase awareness, or is it to map them to some common format?
Yeah, thank you. I'll reiterate, the expected outcome of this is to first get people to participate in a common modeling activity in a way that doesn't require that they change any of their models. So there's a sort of a lowering of the bar. But also, I think that the technical outcome, since we're focusing on the semantic proxy and the mappings and the bindings, what we're expecting and what we'd like to drive is that we have a way for any model to use SDF and the common patterns that are already in the repositories that people have contributed, and the layer of translation and mapping tools to practically do a practical implementation of interoperability and interworking using mapping and binding, instead of trying to go straight to a converged model. So this will give the ability for, say, someone who is using, let's just say, OMA, to try out some of the OCF models, to try out the Bluetooth models. So it's basically opening this up for people to adopt each other's models before we try to adopt a common set of models.
Okay, thanks. That explains it.
And in the meantime, people will have the ability to publish their models in a common language, and it'll reduce the burden of some of the tool sets. You know, the question of, do we use XML or RDF or whatever? Well, there still are those choices, but if SDF provides a reasonable alternative, we think that will be easier for people to adopt also. Okay, any other comments, questions, please? Right, well, let's move on. I'll give you a quick update on IoTschema.org. We started IoTschema.org with basically the same idea, to capture the information models that vendors and other participants in IoT were using to represent their device affordances. That how do you read temperature from a device, etc. How do you turn the light on? How do you change the color, the brightness of the light? So we created an RDF framework that basically follows the property action event pattern that we use in 1DM, and also we use in W3C thing description, and a lot of common models as we have in our sort of landscape. We see that events, actions, and properties, or some abstractions of those, are very, very common in all these models. So what we have in IoTschema.org is a small, useful set of example models for sound levels and motion sensing and lighting control that have been used with W3C in different plug fests, and they do map back and forth to and from SDF based on a path model. So which when in SDF we have consistent paths, and that basically will, or in 1DM with SDF, we have consistent paths, and that basically will give you the identifiers you need for mapping to RDF. But I think that the real interesting thing is, if there is an RDF framework, we don't have to create as many different models to adapt to different RDF systems. The expectation in RDF is more that you'll import a model as it is and then reason about it to do whatever kind of integration into your other model. So that's an interesting point that we need to look at and see how we could deliver RDF models across the space, and maybe it's through translating SDF or something like that. But IoTschema.org, we're leaving it up because people are using it and using it as an examples for semantic annotation and thing descriptions. But there really isn't any governance. It's ad hoc, and the development meetings are paused. We add models as people need to do their demos and thing TD interop plug fests for W3C. But there might be some future there in making it a W3C community group. We started that activity at one point, but right now it's just sort of I guess an experiment. that was moderately successful, but doesn't really have a lot of legs because there are probably other ways to do this that people are more interested in doing with one data model and things like that. So I don't really have a future forward plan for that, but just where it is, we're going to keep it running, and it's only a little bit of a server that runs and a domain registered and stuff like that. But basically, we're not going to try to integrate it with schema.org, because schema.org is more about higher level business concepts and not about device affordances. And I think there's a pretty clear dividing line there. If we do end up producing a higher level IoT conceptual model that might be appropriate for schema.org, that's a different thing. Okay, that's all I have. We need to move on. Any questions, comments?
Yeah, I'm wondering whether we can get those models translated into SDF and include them in the 1DM playground.
That would be an interesting thing to do the other direction translation. I would look into that. Thank you. Other questions, comments? Then I will yield.
Okay, thank you, Michael. Just no more questions or comments on that. Next up is Karsten and SDF update and status. Go ahead, Karsten.
Thank you. So I want to give a really short look at SDF. I think many people who are in this meeting know what's going on there, but maybe it's interesting to see my view of what's going on there. So just to remind people, SDF is the semantic definition format. It started out as a simple definition format, and of course you know that nothing stays simple. over time, even though I still think it's pretty simple for what it does. And the idea is to look at a thing, an IoT thing, and look at its digital side, not the real world side, not the physical side, but the digital side, and describe the interactions that the device can do in terms of affordances. And as Michael has mentioned, we have this property action event. Now I need to reuse the word model. We have way too few words in this space. The scheme of partitioning these affordances into the 3 different kinds, which seems to work reasonably well, and we are following that as well. And we are providing some way to assemble the affordances into things, or actually classes of things, because all of this is at the level of classes. So this was originally started by 1DM, and 1DM submitted the protocol, or the specification on how to write these models to this research group, and we worked on getting an IETF working group working that now is working on that. We have a pretty stable -12. There's still a list of issues that we need to work on, and I don't think going through these issues will take long. But of course, we also have a few items that are really defining something that we have been calling SDF Next. So we have to think about ways of not having to wait for the entire world to come to a standstill before we can ship the RFC. So this is what we are doing right now. And of course, this is not just specification work, but it's also work on tools. And we will hear a talk about one of the tools later today. There is a tool for converting between Yang and SDF. The IETF Yang specification is used for talking to network elements, but there's nothing fundamental that limits it to that. So it's useful to be able to translate back and forth. And the main point of having a common semantic division format is that we can have converters that convert from and to a lot of other ecosystems, and we have them for OMA, OCF, DTDL, WAT, Web of Things, and we have used these converters to populate 1DM's playground, and that's certainly an activity that will continue in parallel. But of course, it's not the working group that does the implementation, so we are just a working group of people who usually have an implementation cooking somewhere. So talking about how we will actually get SDF Next going, there are several documents out there right now that describe various extensions or alternate views at the this space. One is just a different syntax for SDF that is actually meant to be used by humans. So it's not based on JSON, but on YAML, but it also does some other ways of reducing the noise in the specification. So this has no functional component to it, but it just makes it easier to write a spec on the whiteboard or keep it on one slide when you talk about this. The second one is the SDF mapping document that describes a way how an SDF model that exists can be augmented by adding to this model, usually by adding additional qualities. Qualities is the weird name we are using for properties of the model, because the word property already means two things in this space, and using it for a third thing doesn't help. So we call them qualities. So this is a relatively simple approach right now. And what we really need to do here to complete this is make sure we are happy with the simplicity of this document, whether it actually can solve our problems nicely. And then we have two documents that talk about links. One is talking about links at the model level, and one is talking about links as an actual data type to be used in interactions that are provided by the affordances. So one would say here is something about the description of the interactions that you can find more information on in a different place. And the other one is about hello temperature sensor. Please tell that thermostat over there your current temperature in a periodic way. So looking at these two link oriented documents, the distinction that I just made appears to be a very nice and sharp distinction. But of course, that's not entirely sure. So for semantic links, we have an example. We actually have a unit quality in SDF that allows you to tell what unit, a specific number you might find in a property has. And that's great for many models on the model level. But then, of course, there are ecosystems that actually provide units in their interactions. So an OMA device might tell you its unit, and it might even provide a way to switch between Fahrenheit and Celsius or something like that. So it's not as clear cut as it seems. But anyway, we do have these model level links already for reuse and composition. That's called SDF-Ref. And we probably want to do more things than just gluing SDF models together. So that's why we need more relation types than just the one that is implied by an SDF-Ref quality. On the instance level, of course, we need a data type because the information model has to model the data exchange in the interactions, and that data model is based on RFC 8288 web linking. So it's pretty straightforward. And what we now have to find out whether the statements we can make at the model level about what the values of these links will be can actually expressed in this generic data model in a way that makes sense. So what we really need for the continuation of this work is appropriate examples and trying out the mechanisms whether they do the right thing. And that's where I hope we will get some input from this research group. More generally, we are talking about extension points, so we can wrap up SDF base, an SDF base specification. And as I said, this all revolves around qualities. And extending SDF can be as simple as adding qualities, and then you of course need to manage some namespaces. There may be general SDF extensions, there may be ecosystem specific ones, so we have to define how this should be done. This is currently just an issue on the SDF spec, but it seems relatively straightforward to define this, so this will be one of the things to be done next. And then again, we want to validate whether we are doing the right thing here. So that's simple. Not so simple is actually extending the architecture. So for instance, Web of Things has something called protocol bindings. We currently put these into mapping files, but that doesn't really answer the question whether the protocol bindings are can be described in a cross-ecosystem way. And of course, there are also other kinds of ecosystem info for affordances. So we can put these into mapping files. That's the easy part. The not so easy part is how do you actually go one meta level above and say, by the way, a mapping file for Bluetooth typically looks like this, or a mapping file for OMA typically has an OMA object ID somewhere in it. So of course we can write this in English, but maybe we want to have some form of automatic processing there as well. And we don't have an easy way to generalize class level information for entire things or parameters for affordances. So how do you get from a product line description to a specific product description and so on? Yeah, some interesting questions there, which again, where I hope the research group will help. And finally, there are all kinds of other information that go beyond just providing a description of the affordances, such as purpose in life information, part of which a device needs to know, but part of which actually is outward facing. And there's also deployment information such as location. A device doesn't need to know its own location. So that may be somewhere else, but then we need to properly link this together in a way that actually is not brittle. And links to other things where SDF type link already does something, but is that all we need? And more generally, we seem to need locating things at the class level, modeling the instances, but we also need to have a way of actually describing what's going into a specific instance. Okay, I think you will see some of this in the next two talks. So I actually want to stop at this point, but if there are any immediate questions, we should field them now.
Okay, thank you, Karsten. And I guess for all of those interested in more details, you're very welcome to join the 1DM and ASDF sessions. 1DM we have bi-weekly calls, and ASDF will have an interim coming quite soon.
Yeah, I think we have a doodle up for that interim in January. So just look into the ASDF mailing list.
Okay, very good. Then actually we are slightly over time now, so maybe we then move forward. So next we have Jan with the Web of Things update and about the SDF Web of Things conversion. So Jan, should I share your slides from here and pass you the control?
That would be great. Yeah, thank you.
Just a moment. And now you should have the control.
Yeah, that should work. Great. Yeah, thank you. And hello, everyone. Yeah, my name is Jan. I'm a computer science student at the University of Bremen. And in the following, I want to present my results I've obtained from my bachelor's thesis, which dealt with the conversion between SDF and what data models, namely thing descriptions and the newly specified thing models. But first, I want to start with a brief update on the specification process in the WAT working group. And Klaus and Michael may correct me if I got anything wrong here. But as you might know, currently there's the second charter period of the WAT working group, which will last until the end of January. However, there's probably going to be an extension by 3 months due to some delay in the publication process. There are 3 documents which are going to be published in the first half of the next year, namely 1.1 versions of the theme description and architecture specifications, as well as a new discovery specification, which specifies methods for obtaining theme descriptions and discovering things based on their TDs. And from what I've seen, there's going to be the transition to candidate recommendations for these 3 documents later this week. And then in March, there will be the transition to proposed recommendations. And eventually, they will be published as recommendations and web standards by the W3C, if everything goes right. Then there will be a new charter beginning in May, where first of all, a postponed document from this charter period will be published, profile specification, which specifies a profiling mechanism for TDs. It's also a basic HTTP profile. And in this charter period, there will be new deliverables, such as a 2.0 version of the TD specification, but also new deliverables and new topics, such as a stronger focus on protocol bindings. However, the actual topics are still being discussed, and this discussion is going to be finalized until the mid of January. And you can find the current publication schedule as well as the discussion on the new charter topics in the main WOT repository on GitHub, but also, for example, on the WOT wiki, the W3C. Coming to the actual topic of this, the main topic of this talk, the mapping between SDF and WOT and the conversion. I first want to give a brief motivation for this conversion. So, as you probably know, both WOT and SDF are dealing with improving the interoperability in the Internet of Things from different angles. So, SDF primarily focuses on improving the interoperability between ecosystems and their data models by providing universal language, which can be used in conversion processes. And WOT-TD primarily focuses on improving the interoperability between individual device instances. And as they both cover different parts of the interoperability problem in the Internet of Things, they both complement each other quite well. And this makes WOT-TD an interesting conversion target for SDF. However, there's currently not canonical mapping between the 2 data formats or specifications yet. And my thesis wanted to propose a first proposal in this regard, and also provide a converter implementation which can automate this process. And so in contrast to other formats such as Yang, the conversion between SDF and WOT-TD or WOT data models is relatively straightforward due to a number of similarities. For example, both use JSON as their serialization format or for the document format, and they both use similar concepts, namely, for example, interaction affordances for modeling the capabilities of things, so properties, actions, and events, as Michael has already mentioned. And they also use similar terminology inspired by JSON schema.org for data schemas and data qualities. And these similarities can be illustrated with this simple example. So on the left hand, we see an SDF model containing one SDF object describing a smart lamp with one status property containing JSON schema-inspired schema information indicating that the data type used for this property is a string. And we also have some human-readable metadata, namely a label at the object level and a description at the affordance level. And as we can see on the right, when trying to map this information to a thing description, we can, we have a similar structure. So the label from the SDF object can be mapped to a title at the TD level or the top level of the TD, and the property from the SDF model or the SDF object can be mapped to a property at the thing description containing similar information. However, we can also observe two major differences. So on the one hand, we have JSON ID context at the top of the thing description. So every thing description is also a JSON ID document. And also we have instance-specific information in the thing description, namely a security member at the TD level and forms member at the property level containing protocol bindings, which cannot be expressed in the SDF model itself. And this raised two questions. The first of which being first of all, how we can map the what specific vocabulary to SDF. And for this, I used a concept already mentioned by Carsten, the so-called mapping files, which allow for the augmentation of the SDF model. So on the left, we can see the same model as before. And on the right-hand side, we have a map object within this mapping file or JSON object that contains JSON pointers, which indicate where the SDF model on the left is being augmented with what specific vocabulary. And from these two documents, it was possible, for example, to create an augmented SDF model, which could then be converted to a WOT data model. In the other direction, there was the question of how to map SDF models themselves to WOT that are abstract and contain no instance-specific information, since the forms and the security information is actually mandatory in thing descriptions and has to be provided. And to solve this question or this problem, it was possible to use a new concept called thing models, which are a near superset of thing descriptions with fewer constraints that allow to omit the instance-specific information while only requiring the addition of an JSON ID at type annotation, indicating that this is a thing model. And this allowed the mapping of abstract SDF models to the WOT ecosystem. On a high level, the conversion process I've used looked like this. So as we can see here, the thing models are actually acting as intermediaries between thing descriptions on the left side and SDF models and mapping files on the right-hand side. So due to the fact that thing models are almost supersets of thing descriptions, it was possible to only specify the conversion between SDF and thing models, and on the other hand, the conversion between thing descriptions and thing models, and then get the conversion between TDs and SDF models as a corollary as a result. And this enabled me to cover all three types of documents with only two real implementations, so to speak. Yeah, another aspect mentioned or displayed here in the figure is that thing models can also be augmented with additional information. Yeah, but this is not relevant for the rest of this talk. Yeah, besides the problems I've already mentioned, there have been a number of additional challenges during the for the mapping and conversion. So, for example, SDF and WOT use different approaches for nested models or composition. So in WOT documents, we actually have a linking approach for creating hierarchies, while in SDF, as you might know, we can express hierarchies in a single SDF model using the SDF thing class. And eventually it was possible to map these two approaches to each other after making slight adjustments to the SDF thing class in the SDF specifications. However, one challenge was that it is currently not intended to have a self-contained document containing multiple nested TMs or TDs. And therefore, I used an experimental approach called TM or TD collections, where the linking relations are expressed using JSON pointers. Yeah, so this is actually one thing where the WOT specification might be improved in the future. And another challenge was, of course, round tripping. This converting from WOT to SDF, this was relatively easy using mapping files. But in the other direction, it was necessary to use certain additional keywords prefixed with SDF. And this is definitely something that has to be revisited when making a more formal specification of the conversion process or mapping process. And another challenge for round tripping, of course, was when external references have been used. These had to be resolved before converting a document to the other format. Yeah, as I mentioned, I implemented this mapping or conversion as a software using the Python programming language. I published my converter as a library to the Python package repository PyPy. So you can simply install it using the pip package manager and obtain both a library and a CLI tool contained within this library. So you can either use it from the command line or in your own Python project. I also created a web application where you can experiment with the conversion between SDF and WOT models. Currently, this is hosted on a website called Python Anywhere, but I might move this somewhere else eventually. And the converter is also featured in the conversion tool collection compiled by Petri. So you can experiment with the conversion between different formats, including WOT-TD, and compare the results. And I'm always grateful for feedback or any issues that are being raised to improve the converter. And to draw a short conclusion, so eventually it was possible to map WOT data models in SDF to each other quite well. I used some additional concepts, such as mapping files for this. And as it turned out, WOT thing models could be used very well as intermediaries in this process. As an artifact, I obtained or I created a flexible converter implementation in Python, which can be used as a library CLI tool and also a web interface, or provides me a web interface. However, there's still more standardization work and research needed. So there should be some kind of canonical mapping specification in the end. And as has been already mentioned, the question of how to map the linking approaches used in what is also still an open question. So this hasn't been taken into account yet by me. And yeah, as a last point, yeah, there's also still the question of how to deal with nested TMs and TDs and how to include them in a single document. Yeah, and this was it for now. I'm looking forward to any questions or discussions, but I suppose we probably need to move on at this point.
Excellent. Thank you, Jan. Yeah, we are slightly over time, but only a minute or two. So I guess we can have one or two quick questions if anyone has here. My quick question would be like, when and where can we read the thesis to get more into details of your work?
It is almost ready to be published. So yeah, I need to make some minor revisions, and yeah, maybe then I can send a link around, so then you can have a look at the document.
That would be great. Thanks, Jan.
Okay.
Okay, and we can take if there are no immediate questions, we can take follow-ups, I guess, in the 1DM ASDF work. Oh, I see Milan in the queue. Go ahead, Milan. Milan, you can go ahead and unmute.
I'm thinking in operational terms, what is the objective of this work? Is it to prove the feasibility of doing the conversion, or is it to serve as the basis for some automated tools that will do the conversion? I presume at the design time, this thing's a bit heavy to do at runtime at the node level. But in any case, is this a feasibility demonstration objective, or is it to create the tool, a conversion tool?
So creating a conversion tool was certainly one of the objectives, but yeah, another goal of me was to provide a proposal, initial one, for yeah, more mapping between SDF and what that can or that could be used for the standardization process. So yeah, I think I also demonstrated the feasibility, but it was also meant as an input for the standardization process.
Okay. Thank you, Jan. Okay, if no more further questions for immediately, as I said, we can, of course, continue on the list and in the 1D on ASDF sessions on the topic. But then we have our final topic, Ale and Bin, on the knowledge graphs for IoT platform digital twins based on SDF. So let me enable the slide sharing. And now Ale, you should have the control of the slides.
Okay, can everyone hear me?
Yes, we can.
Okay. Yes. So then I will proceed to present the project that I have carried at Ericsson Research with Bin Xiao as my supervisor. And this project is titled Knowledge Graphs for IoT Platform Digital Twins based on SDF, as Ari has mentioned. So the agenda of this presentation is the following. First, I'm going to give a brief description of the background and the research question, followed by a results overview, and also a talk about the key enablers of this project. And then I will dive more deeply into the project itself, starting by describing the test environment we have used, the prototype, and the algorithm we have used to measure the similarity between devices and integrate new devices within the graph. That we will talk about more in detail. And of course, we will finish with the future work and a discussion of the questions that may arise. So first, a brief description of the background and the focus. The project builds a digital twin using like knowledge graphs, which represent, manage, and reason with graph structured knowledge. For this, we are using the fields of knowledge representation and reasoning, being the knowledge representation based on the representation of knowledge as a set of facts and rules. And then we have knowledge reasoning, which allows us using the rules to discover non-explicitly stated facts. Then I guess most of you will be familiar with this concept, but we will develop this digital twin based on an IoT platform, and it's a platform where connected devices that implement sensor and actuators exchange data. And then I want to describe the concept of digital twin, which is a digital model that accurately reflects physical assets. And it's important to differentiate this one to emulations because this digital twin usually is built on automatically relying on real-time data. Sorry, and has a bidirectional information flow with the physical object it models. So in our project, the physical assets will be the real world objects of interest that are connected to the digital twin system. And the digital twin will be, in this case, a knowledge graph presenting these devices, these IoT devices, and how they relate to each other. So the research question we stated was how to design a knowledge handler for a digital twin IoT device platform so that it enables storing knowledge in a knowledge base, querying that knowledge through a query language, and conduct reasoning in that knowledge or knowledge base to get non-explicitly stated facts. And these first three requirements are usually implemented built-in in like the available knowledge graphs. But then we want to focus on the fourth requirement, which is the integration of new unforeseen IoT devices in this stream we are going to model of the IoT platform, which as I said, it will be the main contribution. And here we have an example of what could be this scenario. So imagine we have the IoT platform representing a production line in a manufacturing plant. So this will be divided in two tasks. The underpan configuration, which will be developed by a pickup robot and a piece detector. These are IoT devices. And also the body configuration task, which will be developed by the pickup robot, drilling robot, and so on. So the question here is, if in this stream of data in maybe CoAP or MQTT protocol, if a new message from a device that we still don't have in our graph appears, such as this new pickup robot, how can we interpret this message and integrate this device into the graph of existing devices we have? Now I want to briefly describe the results of this project. This is divided into three main goals we pursued. And the first one was the exploration of the available methods to develop, to store knowledge in a digital twin. We chose to store this knowledge using the TypeDB open source knowledge graph. And then for this graph, we define a domain adapted ontology or schema. And using that schema, we design an initialization of the data. This is the initial devices and their connections based on the physical asset we want to model. And this physical asset since we don't have data from a real physical object or asset available, we decided to emulate it. So the second main goal, was to set up this IoT-based testbed for the knowledge ingestion. This is first, it was divided into the following sub-goals, which is the define the IoT devices. It was based in IoT devices in a simplified automobile production line that can be seen here in the picture on the upper right. Then for each of the devices involved in this production line, we described them semantically using SDF. And these devices are divided in modules, which will be SDF objects, which are divided in attributes, which will be in this case the SDF properties, while the modules will be the objects. Yes. And then we emulated a data generation for each of these devices that depends highly on the task they are developing. The final goal was the integration of the device data into the knowledge graph. And for this, we have made the algorithm able to define each new class of IoT device it detects, which is described by its SDF file in the schema of the knowledge graph, and update the attributes of these devices in real time, as well as being able to integrate new enforcing devices when they appear. So in order to achieve these goals, we have certain key enablers. The first one is the TypeDB knowledge graph, which is divided into the schema and the data. First, the schema is describing the ontological description, which would be the backbone of this graph. And it represents domain-specific terminology that defines the objects in this graph and how they relate to each other. So in this graph, we will have three main types, which are entities, which are the objects involved in this graph. For example, in this simple schema for a phone calls knowledge graph, we have that the entities are persons and companies. And then we have another type, which is the relationship, which are NRE connections based on roles. So for this simplified schema for phone calls, this would be the contract. And these are based on roles, which state the directivity of these relations. So a contract will have a provider, which can be played by a company, and a customer, which can be played by a person. And so on. This will be similar for the relationship of the call that has a caller, which is a person, and a callee, that's also a person. And then the last type we have in this schema definition is the attributes, which are the actual values that are owned by entities. That could be for the person, could be a name, a phone number, a city, and an age. And as most databases, this TypeDB has its own query language, which is called query TypeQL. So in order to define a schema like this one, we will execute the defining query we have here. So for example, for the contract, we will define it as a type of relation, so sub-relation, and then it will relate a provider with a customer, which we saw here. For example, if we then dive deeply into the entity company, it will be a sub-entity, and it will be play the role of the role provider in the relationship contract, and it will own a name. Then, as in the knowledge graph, we also have the data, which are the actual entities under instances and relationships. So for the basic example of the phone calls knowledge graph we talked about before, we could define a company such as Ericsson, and two persons such as me and John Legend, and then we can also insert some calls between these persons with a certain duration, and give specific names to the persons, as we can see on the graph on the right. Then the second key enabler is SDF, which you are, of course, familiar with, the semantic definition format. And we have used this format to define a semantic JSON description of each IoT device class, which is divided in modules, attributes, and value types. So it like specifies the modules, the attributes, and value types that each IoT device has. So this is done with the goal of understanding each device, each IoT device, as an instance of a class of IoT devices, which is defined by its SDF description. So in the case of an air quality IoT device, which we have here, we will have one will be divided in several modules, which are SDF objects, which are the temperature sensor, the humidity sensor, the pressure, and the air quality sensor. And each of these modules, which will have at the same time some properties, or as I call them, attributes, as they are calling the knowledge graph attributes, which will be the temperature in this case, which are a certain type and a unit. And it is also important that since they are defining, since SDF format is used to define classes of devices, they will also implement a UUID attribute, whose goal is to identify each instance of a certain device class. So this the goal of this SDF description then is that each time we detect a device in the stream of data we are listening to, that is not whose class is not yet defined in the schema, so the class is unknown, we will query this SDF description, and using this description we will automatically generate a query or defining query with type QL, that will look like the one we have in blue in the bottom. And through this query, we will define the schema for this specific IoT device class inside the knowledge graph automatically, which will look like we have in the lower right of the slide. So now that we have defined described the background on the key enablers, we were going to dive more deeply into the job done. So we will start by describing the test environment, which, as I said, is based on IoT devices in a car manufacturing plant. And then we're going to talk about the prototype, which is divided in the key components description and the data flow. And then we will end with the algorithm that we have used to measure similarity between devices, which is divided into the class similarity and the instance similarity or behavioral similarity. So first, talking about the environment, it's based on a car manufacturing plant divided in tasks. And as I said before, the knowledge graph requires us to define a schema based on the domain. So for this manufacturing plant, we design a simple schema to model how the devices relate between each other and what role do they take in the environment. This is based on this schema has a department that is related by an execution relation to a task. And then this task will have a predecessor, a successor, which is it's the same type task. So each type will be there will be a sequence of tasks, and each in this task will play the role predecessor, successor, depending on the link between them. And then the task will need an IoT device, which is called device in the schema, which will at the same time include a set of modules that will be defined by the SDF description of the specific IoT class. And then we have, apart from the schema, we have the data. So for the data we use, we design an initialization for the IoT platform that defines an initial set of tasks, which is an object of the schema and their devices adapted to the schema. So we have two departments in this environment, the production department and the safety environmental. And within the production department, we have the initialization task that includes a tag scanner device and a production control device and also the underpan configuration task that has a pickup robot device and a piece detector, and so on. And the same will apply for the safety environmental department and the task of indoors monitorization, outdoors control, monitorization, and safety alarms. So now we're going to talk about the key components of this prototype. And I want to start with from the right of the slide. So first, we will have a set of scripts, specifically the script that defines the physical object or the emulates the physical object or the IoT platform. And this will define a set of IoT device classes that will be implemented through threads and MQTT clients. Where we have decided to use MQTT just because it was not the focus of our project how the devices communicate, but to make it seem simple. But we could have also implemented it with co-op. So these devices will publish messages to a broker on specific topics, and in the header of this message, it will be the UUID specifying which instance the device is, the device name that will relate to the class of the IoT device, and the timestamp saying when the data was generated. And then also the body with the task-dependent actual device data. So these messages will be published on topics to the broker, and then they will be sent from the broker back to the then it will be sent by the broker to the MQTT client that will receive and process these messages, and then send them to the consistency handler that will actually process the information of these messages and define new device classes in the schema if necessary, update their attributes, and integrate new unforeseen devices. And then, since it needs to update the information in the knowledge graph, it will be these updates that are necessary to be done on the graph will be handled by the TypeDB client that will generate the query automatically and send it to the actual database with the knowledge graph to update the information necessary. So here we have the flowchart of how this algorithm that we have just talked about of the consistency handler works. It starts from an idle point where we are waiting to receive a message from an IoT device. So in case we receive a message, this message is decoded, and this message is divided in the header, as we talked before, with specifying the name or the class of the IoT device and the UUID of this device. And then we have also the body, which specifies the actual values that this device has. So what we will ask ourselves first is the class of this device known? And in case it is not known, we will define the device class in the knowledge graph schema using the SDF description. So as we said before, we will turn the SDF description of the device into this query automatically to define it into the schema of the graph. And then once this is done, we will ask the following question: do we know the actual device instance? So this is like, do we have the UUID already in our known devices? And in case the device is not known, so we will insert a floating device in the knowledge graph where floating means it is inside the graph already, but it doesn't have any relation. So it's like floating on the graph. And go to the next step, which is to update the device, the actual attributes or values of the device. And as we said, in case this device is not known, we will repeat this until we have enough samples to analyze the time series behavior of this device, and then go to the next step, which is the find closest device within those integrated in the knowledge graph. The algorithm we use to measure similarity will be explained in continuation. But if this algorithm finds there is a really similar device, what we will do is we will replicate the relationship of the relations of the closest device and the new device, and check if it was active lately. In case it was, consider the new device as complementary and keep the closest device. And in case it wasn't, replace the older device. Consider a replacement took place. So remove the older device from the graph and put the newer one in its place. And then we will go back to the idle state. So I want to end up by explaining how we measure the similarity between devices. So the similarity measure is divided into device class similarity and and instance similarity. And to measure similarity between classes of devices, we're comparing their SDF descriptions. And to do that, we turn them into table, which eases the analysis but adds a bit of redundancy. And the problems we encountered to measure this distance was that how can we compute that distance based on string values, which for what we use natural language processing tools. And then the other problem was how to compare device classes with different number of properties. For what we use a row-wise voting system that we are going to explain briefly in continuation. So to compare devices with different number of properties, what we did is take a row of this SDF description, defining a branch of the description. So it would be a certain attribute. And we will compare this class SDF row to all of the possible rows or attributes in the other already integrated classes in the graph. We will determine somehow which one is the closest one semantically. And for this closest row, we will look at what class it belongs to and give this class a vote. So if we repeat this process for all the attributes this air quality simplified new device that appears in the stream has, we will get at the end that the closest device is the air quality device, which is not simplified, it's a bit more complex device, but they're doing the same job. So since it was the closest class, or the one with the most votes, what we will do is integrate this inference using the SDF relation into the SDF description. So now we will say in the description of the air quality simplified, we will add an SDF relation saying that it's the same as or similar to an air quality device class. And we also need to compare then to be able to see which device is behaving closer to the device we want to integrate within the graph. So for this, we also look at the attributes, but now we look at the series of values, the time series of values they have around time. And we search for which other device has this most similar behavior in the last period of time through the comparison of a sliding window, which we can see for the pickup robot new device in green here. So what we will do is take the sliding windows of the last values of these attributes of this unknown device and slide it through all of the other possible attributes of the closest classes device entities and see which ones are the closer one. So we will vote the closer class for each of these attributes, and as said before, get the closest device as the one with the most votes. And I was gonna do a quick demo, but I think I'm a bit I don't have enough time, so I'm gonna skip it for now. And if in case someone is interested in seeing it, maybe I can run it afterwards. So I'm gonna talk about the future work of this project, which is probably looking on the generation of automatic generation of SDF description from the device specification. We also need to look on the optimization of the closest device, the computation of the most similar devices. This is the class and behavioral distance, because it's a bit too slow at the moment, and it could be made more fast. And then we are also we don't tackle the integration of new devices from scratch. This is that if in case we don't find any really similar devices within the graph to the new device, we don't have a process yet to integrate the new device, but it will require creating a new branch within this graph. And then we also need to test this this project with real data coming from an actual IoT platform. With this, I end the presentation. I'm open for questions.
Excellent. Thank you, Ale. And we have Michael Koster in the queue. Go ahead, Michael.
Great. It took a while to unmute. Thank you. This is awesome work, and this is very closely parallel some work that that I was just doing also, which is basically how do you make models for things that you don't yet know about. But my question is, how much standardization are you assuming that already exists in the terms of an SDF, say, vocabulary? If you encounter the term temperature, do you expect that, you know, how much fuzzy reasoning are you doing to sort of try to harmonize different models, or are you expecting vocabularies to already be harmonized here?
Maybe I can answer this question for that. That's first a very good question. And just to say, we are not following up with the vocabulary ones. And meanwhile, we are very much open for different type of identified vocabularies for the SDF notation. That's because the way we are doing is actually a calculating distance. Then the only question is that it doesn't matter what are in the dictionary or not. Once we annotated use SDF, then you can always try to find and search in the current existing knowledge graph if there be anything close to that using the distance calculation we have. And if they've been do, let's say, close on the distance, then things can be integrated with the new data to the existing knowledge graph. I hope I answered the question in this way.
That's great. Thank you. Very sensible approach also.
Okay, thank you. Guess we have for a very quick comment, or well, not really, we're practically out of time here. That's actually true. But what we could definitely do is to have the demo in one of the 1DM or ASDF sessions that we could take a closer look, since we didn't have unfortunate time for it today. But thanks a lot for presenting, Ale. I think this was very interesting and relevant work here. So what we could do now is to wrap up here. We already identified a couple of ways forward, especially with the documents. So thank you everyone for showing your support on adoption, and looking forward to all the reviews on the documents. When it comes to the presented work around SDF, yes, let's continue the discussions in the 1DM calls, in the ASDF calls that are coming, and also on all the security topics. You will be hearing more on the SecCore on the mailing list. And anything else? Any other final comments before we close for today? Okay, in that case, thank you everyone for joining today, and looking forward to see you in the follow-up work meetings and also in the following summary meetings of the Think Learning Research Group. Let's stay in touch.
Thank you. Bye.
Thank you. Bye.
Eigenvalues for text.